Okay, I'm going to look at page 28, page 25, number 28, and this is a supply and demand. So here you can see it's a demand function. It says demand as a function of quantity. So that means quantity is your input, price is your output, and again, the D stands for that this is a demand function. And then here again, quantity is your input, price is your output, and S stands for the fact that this is a supply function, so that you can kind of keep track of them. All right, so this one is talking about strawberries. Now, again, be careful if the units are in different things. So here it says prices in money, which is great, dollars. Quarts, the quantity is in per 100 for the quarts. So again, if you get an answer of 3, it really means 300 quarts, so just be cautious of that, so be careful. All right, so part A says, okay, so what if you have 0 quarts, and what are we dealing with here? We are dealing with the demand function. So that tells us we're using the top one here. And it says, okay, what if you have 0 quarts? So again, you can tell quarts is input, so you're going to shove input into the demand function, right? And so 5 minus, and you're just going to do order of operations here. Multiplying by 0 gives you 0. 5 minus 0 is 5. And then again, your output when you shove in input is price. So this is $5. All right, so that would be $5. Let's look at B. On B, they say, what if you have 400 quarts? All right, now again, be a little careful. If you shove 400 into there, it's going to be negative. That doesn't make sense. So remember, quantities are in terms of hundreds. So this is really an input of 4. So I'm going to input 4 into my formula. And 5 minus 1 is 4. And again, that's price, $4. Okay. So that's input. And then the other thing I could do is I could give you the output and have you figure out the input. So let's look at, say, E. All right. E is, okay, when would the price be $3.25? And again, we're still dealing with demand function right now. So, but that's the output because price is your output. So I have 325 equals, that's my output, 5 minus 2.5Q, subtract the 5. And let's see if I can do some mental math on a Friday night. Looks like it's that, hopefully. All right, divide. Right, and let's see, so Q equals, let's see, 25 cents goes in $1 4 times, 25 cents go in 75 cents 3. So that should be 7. And again, you can use a calculator. I'm just being lazy here. Now remember, that's not 7 quarts because quarts are in terms of hundreds. So this is actually, you have to be careful. This is 7, well, if I quit breaking my mechanical. So this is 700 quarts of strawberries. So that time they gave me an output and I have to solve for the input, okay? All right, the other thing that we do with these is we tend to graph these and we also look for the equilibrium point. So we look for the equilibrium price, which in this case is the output, and we look for the equilibrium quantity, right? And again, that's my quantity. So I want to know when supply and demand equal. Oh, I'm sorry. And again, I could also I could shove into the supply function too. Let's get this first and then I can come back and do that. So if I want to know kind of what the ideal amount is, I'm going to set supply equal to demand because we kind of want to balance them both out, right? We want to make sure we can kind of keep track of both. I'm going to add my Q's to the same side. 5 equals, and that equals 0.50Q. And then divide by a half. Those cancel. And again, if you're dividing by, in a sense, 50 cents, is that okay? That would go in there 10 times because 50 cents goes into $1 twice, and I have 5 of them, so that would be 10. All right, but again, that's Q equals 10, which really isn't 10, right? Like each quart is worth 100. So that's actually 1,000 quarts of strawberries, okay? Now, I solve for Q, but I want to know price. Well, either one of these, remember, the output to this is price, the output of this is price. So it doesn't really matter which one you shove it into. I'm just going to take this 10, sub it into this one. Again, if you wanted to sub it in over here, it doesn't matter. 2.25 times 10 is $2.50. All right, so that would be the equilibrium price. So this is your equilibrium price. This is your equilibrium quantity. All right, the one thing I didn't do up here is I didn't shove anything into the supply function. These were all demand. So let's go ahead. We could do the same thing we did here, except with the supply function. So let's just do a couple of those quick. So let's write down the supply function again. And then P. And again, this is just here to let you know that you're dealing with a supply. If it looked like this, you wouldn't be able to tell if it's supply or demand. So that's why that's there to say, oh, we're doing the supply function where the input is Q, and then we're kind of given the formula. All right, so let's look at these. Let's look down at I. Okay, and I says $2. Okay, so we're looking at the supply and trying to find quarts. Now, again, this is output because price is output, quantity is input. So I'm going to put 2 equals, and again, this is just to tell you that it's a supply function. No big deal. Divide by 0.25, 0.25. And do you see how there's no adding and subtracting this? That's why I don't add or subtract when I solve it. There's only multiply, so you always do the reverse, which is divide. And again, you can divide this on a calculator. I'm just going to think of it this way. A quarter goes into a dollar 4 times, so I would double that. That's going to end up being 8. But again, if you don't want to do it mentally, use a calculator. All right, now again, this is quantities, so remember that's not really 8, it's really 800 quarts. Okay, and then I could do the same thing on this one. I guess they don't have you, but yeah, if they gave you quantity, you just plug it in. So again, they don't have you do that, but say they give you 900 quarts. Okay, that's input, right? But again, you're only going to input 9, right? And let's see, 9 quarters would be what? 4 would be $1, another 4 is at $2.25, I think. You guys can keep me honest. So take 9 times that, hopefully it's that. Okay, now the other thing we do is we graph to get this equilibrium point. So we can graph it, we can get the answer by doing algebra, but we always can get it by graphing as well. And since these are, you know, they're solved for y, I'm going to do it on my graphing calculator, but I'll also do it on Desmos for those of you that don't have one. So here's my calculator. Let me put the light on for a second, see if that helps with some of the reflection, maybe. All right, so I'm going to sub in 5 minus 0.25x for my first one. And then I'm going to do the other one, which is y2 0.25x. And I'm just going to go to a standard window, which again is 10, negative 10. Usually that works. The nice thing is you know the answers, so you know that Q is 10 and that's 250. So do you see how it's on the edge of the screen where 10 is, which should not surprise me because I got Q equal 10. So what I'm going to do is I'm going to go to my window and I'm just going to make it a little bit bigger on the X because my X is kind of getting cut off there. So I'm going to go 20 on my X. The other things I can see, so I'm okay with that. I just want to see where they cross better, not at the end of my screen. So all I did is just make this a little longer so I could see. Okay, to see where they cross, hit second, calculate, and intersect. So number 5, 1, 2, 3, right there. So there's your input, 10, right there. Input is 10, and output is 250. Now again, remember input is quarts, so that's really 1,000 quarts, but the output is money, which is fine, $2.50. Okay, I'm going to do that equilibrium point on Desmos too. So let's see, let me get out of this screen and I am going to open up Desmos here. And let me see if I can move this over so that you can guys see. Okay, so I'm going to do y equals, and again, when you're graphing lines, you actually use equal. When you're trying to do linear regression and have it come up with the r value and all that stuff, you have to do the y1 and then x, which is nice. Okay, so we don't use the tilde and we just use y's and x's. So what's my other equation? 0.25 x. Okay, and again, the nice thing with this is I can just pull it to see. And if I, oh, can we get on that line? Usually when you hover, why is it not showing me? There we go. Okay, 10, and so I had to click on the intersection point. I couldn't just hover. So 10 is your input, 250 is your output. Again, 10 is really 1,000 quarts of strawberries, and then 2.5 is really $2.50. So that's how you get the equilibrium point, by graphing our Desmos. All right, I hope that helps you guys out with supply and demand. If you have other questions, let me know, and I will try to help you. Take care and have a good weekend.